Okay, so let's just take a quick look. Now, I'm assuming we did number 1 together, correct? Okay, so I'm starting off basically on number 2 then. Okay, milligrams in a gram. What I'm expecting to see if you can actually see what I'm doing here. Okay, so what I expect to see for work here, I start out with what I'm given. I've got 1 gram. Automatically, my conversion factor, I am told by dimensional analysis, gram shows up in the denominator, and then because I'm going to milligrams, the milligram shows up in the numerator. My conversion says 1 milligram is 10 to the minus 3 grams. My answer then is 1 times 10 to the positive third milligrams, or 1,000 milligrams. Both are correct. Questions, confusions? Okay, nanometers in a meter. Okay, I have the fact, I have 1 meter. Automatically, if meters is not in my final answer, meter shows up in the denominator. I am always going to or from my base unit in a prefix system. Always. So we do this, then I have nanometers up here. My rule is 1 nanometer, 10 to the minus 9 meters. Which means my answer is 1 times 10 to the 9th nanometers, or 1 followed by 9 zeros nanometers. Again, you do not have to write in scientific notation unless you are specifically asked to, or you have to show your significant digits. Questions, confusions on that? Okay. Those hopefully were fairly straightforward. Next one says, I want to go to kilometers from centimeters. Okay, I'm going to get a little more complicated. I start out with what I'm given. It asks me, determine the possible equalities between the units in the problem and meters. So I have the fact, I have 2 quantities. I have kilometers and I have centimeters. We do not go directly between them. We go through the base unit of meters. That's how everything's defined. So I need to set both of these equal to meters. So I have the fact that 1 kilometer equals 10 to the 3rd meters. I have that 1 meter equals, let's try that the other way, that I have 1 centimeter equals 10 to the negative 2 meters. Those are my possible equalities. So that would be what would go in the blank for A. It asks for the possible equalities between the units in the problem and meters. Rewrite these equalities as conversion factors. How many conversion factors should I get out of this? 4 is absolutely correct. Thank you. So, always, if you have an equivalence A over B, this yields 2 conversion factors. A over B, which is equal to B over A, which equals 1. because they are equivalent. So I have 1 kilometer per 1,000 meters. And if you wanted to write it out as 1,000 instead of 10 to the third, that's fine. I do it that way because it's just quicker. Or I could write it as 1,000 meters per 1 kilometer. Absolutely correct. There's my 2 conversion factors from here. Same thing. Here I could write it as 1 centimeter per 10 to the minus 2 meters, 10 to the minus 2 meters per 1 centimeter. Equivalent to this is the fact that 100 centimeters per 1 meter, or 1 meter per 100 centimeters. They mean the same thing, just so you know. But there's my 4 conversion factors. That's what I'm asking for, the 4 conversion factors. That should be B, where it said rewrite these equalities as conversion factors. Then, decide which conversion factors will give the correct unit. Well, what do I need to do to figure that out? I need to know where I start. So in C, I did this, 987 centimeters. Lost my place. Well, what do I know right away? Dimensional analysis tells me centimeters has to go in the denominator, which means meters goes in the numerator. Remember, any of these prefixed units, my conversion factor will always have the prefix unit and the base unit. Always. No need to think, no need to struggle. It's always going to do that. So centimeters goes in the denominator to cross cancel, which means I'm using this one. So I plug in 10 to the minus 2 and 1. I'm at meters. I want to go all the way to kilometers. I am not done. That tells me automatically meter shows up in the denominator to cross cancel. That tells me then kilometers shows up in the numerator. Just looking at my dimensions, I get the correct unit. That's called dimensional analysis. It's a very powerful little tool. Then I just fill in the blank here. 1 kilometer per 1,000 meters. Now I do the work. Quickly in my head, I've dealt with my units, so I know I'm ending up with kilometers. I'm going to have 987. I deal with my powers of 10. 10 to the negative 2 divided by 10 to the third gives me times 10 to the negative 5. And that would be kilometers. That is not correct in the fact that it's not correct scientific notation. The answer is correct, though. What do I have to do now? To write this in correct scientific notation, I would move this over 2 places. If I move it over 2 places, that means I'd add 2 to that. And this becomes 9.87 times 10 to the negative 3 kilometers. If I simply wanted to write it as a number, not in scientific notation, this says I have to move that decimal point over 5 places. So I go over here, and so I would end up as 0.00987 kilometers. Yes, no, maybe? Seem good? Wilhelm, good? Yeah? Ethan? Cool. Alrighty. Now, these problems are going to be very repetitive because they're all basically done this way. So then, looking at the next problem, number 4, I'm converting kilometers to millimeters. Well, that's what I do. I start with 89.3 kilometers. Automatically, kilometers goes in the denominator to cross cancel. No hard thinking. That's just the way it is. Always through my base units. That tells me meters goes right there. No hard thinking. Just accept it. Go with it. Am I done? The answer is no, because I want to get to millimeters, which means meters has to go in the denominator here. My unit I want to go to is here. Anytime I'm changing in the prefix system, at most I will have 2 steps. That's it. Because I'm either going to or from the base unit. That's how everything is defined. So my first step, look at it dimensionally. My second step, fill in the values. 1 kilometer, 10 to the 3rd meters. How do I know that? I'm supposed to know my prefixes. So have that little sheet, get it stuck in your brain. Then, millimeters, 1 millimeter, 10 to the minus 3 meters. My problem is now set up. I'm telling you exactly what I need to do to solve the problem. Dimensionally, I'm good. I'm in the unit I want. Mathematically then, I look at coefficients, I look at powers, I look at units separately. So I get 89.3. 10 to the 3rd divided by negative 10 to the 3rd times 10 to the positive 6 millimeters. Now, this is not in correct scientific notation, but it is useful notation. Okay, so I can write my answer in 2 ways. If I'm going to do in scientific notation, I notice this doesn't work. If I have to move this over to here, that means I have to add 1 to this. My answer becomes 8.93 times 10 to the 7 millimeters. If I simply want to write the answer in regular notation, this means I need to go this way 6 places. So my number then becomes 893,000,000, put in my commas for spaces, millimeters. Either one of these answers is correct. So either one of these would be what would go into the blank. That's all there is to it. Again, these problems hopefully are going to become quite repetitive rather soon, which is good. We want them to be. Now, I am trying to see if this works. I am recording right now what we're doing on the board, and I will eventually try to post this for you. If it turns out this time and doesn't freeze. I tried to record last time for you guys. The iPad I had set up just died. It froze, I don't know, too much memory, who knows. But I'm trying it again, so we're seeing if we can get this to work. Now, problem B. I've got 1 megagram, notice the capital M, I want to change to milligrams. Well, right away, megagram is not my answer. It has to go in the denominator to cross cancel. Grams is not my final answer, so grams goes in the denominator, and I go to what I want, which is milligrams. 2 steps. That's the most you're going to have to do with our prefix system. Now it's a matter of filling in the blanks. Mega means million. That's 10 to the 6th. Milli means thousandth. That means 10 to the minus 3. I do the work. These all cancel, leaving me the correct unit, so I'm looking at it in 3 parts. Coefficient, unit, and power. Well, this is 1 times 10 to the positive 9, 10 to the 6th divided by 10 to the negative 3rd, 10 to the 6 divided by 10 to the negative third. When I have the same base and I'm dividing, I subtract the denominator. That gives me 10 to the positive 9 and milligrams. That is my correct answer in scientific notation. Or I could have simply wrote 1 billion. Now again, probably remind you that this billion, Latin, 2. But I got 3 sets of zeros. The way we do it is that prefix is past the first set of 3. So there's 2 more thousands group past the first one. That's billion. When I go trillion, it would be 3 sets of thousands past the first one. Quadrillion, etc. Just so you know. So this one, I have 1 billion milligrams. Yes, no, maybe? Still good? Awesome. Micrograms now in centigrams. Again, I do the same thing. I start out, so I'm on problem C now. I've got 15 centigrams. I want to go to micrograms. Centigrams is not in my final answer. I cross-cancel. Grams is my base unit. I put that there. Grams here to micro, that Greek symbol, mu. Tail in front of basically a cursive U. So we have micrograms. I fill in. 1 centigram is 100th of a gram. 1 microgram is 1/1,000,000th of a gram. Again, my units cancel. I'm in the correct unit. So that I look at exponents. Sorry, I have my powers, my exponents, my coefficient. Well, this simply turns into 15 times 10 to the positive 4 micrograms. This answer is meaningful, but it's not correct. I need to have it in my metric prefix. I need to have it either as scientific notation or as a number. Scientific notation, I move this over, add 1. This becomes 1.5 times 10 to the 5th micrograms. Or I could write it simply as a number. This says, go 4 spaces to the right. I could have 150,000 and micrograms. Both answers are correct. Next problem is micrometers from nanometers. So, 2,500 nanometers. Nanometers is not my final answer. Nanometers goes in the denominator. My base unit then will go in the numerator. If my unit is on the denominator, this has to go on top. Meters is not my final unit, so therefore I put meters in the denominator. And I go to my final unit, which is micrometers. I simply plug in 10 to the minus 9 to 1 nanometer. 10 to the minus 6, 1, and 10 to the minus 6. Simply solving my problem. Units are now taken care of. I'm in micrometers, which I want. I only have 1 coefficient. I leave it alone for the moment. This is what I get. Dealing with my powers then, this is 10 to the minus 3. And this is then in micrometers. Okay, useful, but not a practical way of doing this. This then turns out, if I change this to scientific notation, I gone 1, 2, 3, 4 places over, 2 significant digits. So I add 4 to this, and this becomes 2.5 times 10 to the 1 micrometers. Or I could simply write it as 25 micrometers. Yes, no, maybe? So, going on. I've got grams and nanograms. Okay? 5.67 nanograms. Nanograms is not what I want. Grams is one step. 1 nanogram, 10 to the minus 9 grams. That's my definition. My answer works out just peachy in scientific notation, times 10 to the minus 9 grams. If I want to write it in regular notation, that means I need to move this over 9 places. So I get 0.00000000567 grams, which is also correct. I just think it's easier to write it like this once you get the hang of it. So again, I went over 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places to get the decimal point there. Millimeters and 54 kilometers. I've got 54 kilometers. Automatically, kilometers goes in my denominator to cross cancel. My base unit goes on top. I'm not done. I want to get to millimeters. So that means meters in the denominator, millimeters on top. Dimensional analysis, I've chose the correct units to get to where I need to be. I come here and fill in 10 to the third, 1. 1, 10 to the minus third. Solving simply my units. I got millimeters, great. Coefficients, just 54. So I get 54. My powers then, my exponents here, I get times 10 to the 6th. 10 to the positive third divided by 10 to the negative third goes in 1,000,000 times. And then my unit. This is not the correct units for the answer. To do this, if I'm going from here to here in scientific notation, it becomes 5.4 times 10 to the 7. If I go this direction to fit the decimal point in, I had to add 1. Or, if I'm going to write it out, this says add 6 zeros behind this 4, or I get 54 million millimeters. Yes, no? Maybe so. Starting to look pretty repetitive. Starting to make a little bit of sense. Okay. Yes, ma'am.
So when you have a negative exponent in the denominator, you add it?
Okay. Whatever I have here, if I'm doing this, b to the n divided by b to the m, the rule is this answer becomes b to the n minus m. That's my math rule. So if this is negative 3, if b is 10, so this is 10 to the third divided by 10 to the negative third, my answer is 10 to the 3 subtract. So if I subtract a negative, it's the same as adding a positive. Okay. centimeters in millimeters. So we got 0.62 millimeters. We're trying to convert to centimeters. Millimeters is not my final answer. Meters is my base unit. Meters is not my final answer. So I put it here to cross cancel. Centimeters is where I want to be. I plug in 1 millimeter, 10 to the minus 3 meters. 1 centimeter, 10 to the minus 2 meters. If I do this, if I'm going from millimeters to centimeters, I expect the number to get smaller because I'm going to a bigger unit. Okay, this is like from going from pennies to dimes. Okay, so when I do this, my answer, 0.62 millimeters, or sorry, 0.62, coefficient hasn't changed yet. I've got 10 to the third, 10 to the minus 2. This is times 10 to the negative 1, and this is centimeters. Useful notation, not the correct answer. All I did was treat my units, treat my powers, treat my coefficients. To get this in correct scientific notation, I'm going to go this way, which means if I'm going that way, I have to subtract 1 here. This becomes 6.2 times 10 to the negative 2 centimeters. Or, if I simply want to write this number as a number, this just means move the decimal point 1 more place to the left, so I could get 0.062 centimeters. Either one of those is the correct answer. Didn't ask for you or tell you that you had to write it in scientific notation. So we have this. Then we had milliliters in 22.4 liters. So we start 22.4 liters times the fact. Well, liters I want to cancel. Milliliters goes on top. One step. I have the fact for 1 milliliter. There are 10 to the negative third liters. My units are correct. I'm at milliliters. Great, that's what I wanted. My coefficient is simply 22.4. I've got 10 to the 0 divided by 10 to the negative third should give me a 10 to the positive 3. So this would be times 10 to the positive 3. Useful notation, not correct notation. So then I have to choose. Am I going to leave it in scientific notation or not? If I'm leaving it in scientific notation, I'm going to move this over and add 1. So this becomes 2.24 times 10 to the 4 milliliters. If I'm going to simply write it as a number, this says move this over 3 places. So I get 22400, or 22,400 milliliters. Either one of those is a correct answer. Okay, for a party, you bought a 2-liter bottle of cola. Part A says convert milliliters. So I have 2 liters times the fact. I want milliliters as my answer. Liters goes in the denominator, cross cancel. This is 10 to the minus 3. This is 1. I get 2,000 milliliters, or 2 times 10 to the third milliliters. That would be part A for 6. How many glasses can you fill? Here's where I have to come up with my own equivalents. 1 glass equals 200 milliliters. I was given that in the problem. There's my equivalents. I get 2 conversion factors. It's either 200 milliliters per 1 glass, or 1 glass per 200 milliliters. I plug in 2,000 milliliters times the fact, well, I want glasses as my answer. Milliliters is going to cancel. I want to use this conversion factor. So it is 1 glass per 200 milliliters. I get an answer that is 10 glass. So, this was not explicitly given to you, but it was given to you. When they said that a glass holds 200 milliliters, they're telling you, there's your equivalence. Okay, the last problem that I'd ask you to work to. Okay, for your experiment, you're doing something with bicarbonate of soda, sodium bicarbonate, baking soda, whatever you want to call it. You've got 3 different jars, and you want to know if you have enough. Well, what you need to do is basically this. You need to convert all to the same unit. How did I do this? Well, I said I took 454 grams plus 350 grams and got 804 grams. This particular problem, I'm not so worried about significant figures. So I'll let the 350 slide and use this number. I then need to convert to kilograms. That's what my other units are. So I will take 804 grams times the fact. There is 1 kilogram per every 10 to the 3rd grams, and get 0.804 kilograms. To know if I have enough, I'm actually saying if I take what I have less what I need, I should have greater than or equal to 0. That's basically what I'm saying. This is what you're kind of thinking in your head if you're trying to figure out if you have enough. So what am I going to do? I'm going to take this 0.804 plus the 250 they said I had in this other container. I'm going to add those, and then I'm going to subtract 1.20. If I add these two together, don't I get 1.054 kilograms minus 1.20 kilograms? And that is not greater than or equal to 0. I do believe I am short 0.146 kilograms. So no. Again, we're just trying to formalize what you would be doing in your head. If I'm doing this problem, I've got 3 different containers. I need to add the masses up in each container of stuff I have. And then what I'm trying to do is say, this is how much I need, this is how much I have. I need to take how much I have, subtract what I need. And if it works, if I have enough to do the experiment, the answer has to be greater than or equal to 0. Reasonable? Or at least as long as I'm explaining it, it's reasonable. The minute I disappear, it starts to look unreasonable again. Okay. Then, volume in SI units. Kind of moving on. A thing we need to know, you need to put this in your head. 1 centimeter cubed equals 1 milliliter for volume. This tends to be a dry weight. So like if I were looking at crystals or sand or something like that, I would tend to do it in cubic centimeters. This tends to be a liquid measure, a fluid measure. So if I'm measuring air, or I'm measuring water, or I'm measuring medicine, you may have remembered hearing in old medical shows where they talk about give them 50 cc's of thorazine or something, or epinephrine or whatever. cc stands for cubic centimeter. Cubic centimeter. Centimeter cubed. So they have that. If you listen to those shows, like they're trying to save the guy that's having a heart attack, they're always giving him like an epi shot or some sort of, whatever they call that. What are your words? But that's what, you need to have this to do some of these problems we're going to get to. So looking at the problem. So taking a look at this, we should now be here. So volume in SI units. Volume is a measure of the 3 dimensions of an object, length, width, and height. Okay? Unit 1 cubic centimeter is equal to 1 milliliter. Keep that in mind. So if we have a box that is 12 centimeters by 25 centimeters by 15 centimeters, length is supposed to, in general, be the longest measure. The other's height depends on how it's setting. And the same thing with width, depends on how things are setting. If we took this box and did the calculation and got it in correct significant digits, we'd have 4,500 cubic centimeters. Well, we want to convert from cubic centimeters to milliliters. It's pretty simple. It's a one-to-one relationship. Then we need to get to liters, which is the 1 to 1,000. So we do all those conversions, and we get to the fact that box should be 4.5 liters. 2 significant figures, again, because the 1 milliliter, 1 cubic centimeter, and 1 liter is 1,000 milliliters are exact. So then we want to look at problem number 8 here, and we want to work through it together. So that's where I'm at now, and that's where we'll end up. Just enough time to fit that in. So, we have that. So that's where I'm at right now. This gets a little more complex. It's still the same type of problem. It just gets a little more complex. So as I do this, we want to know the volume in liters of a box that measures 1 by 2 by 5. Could you guys fit in a 1 by 2 by 5 box? In meters, this is 1 meter. Okay, I can stand up in a 2 meter box easily. And if it's 1 meter wide by 5 meters long and 2 meters high, all of you could fit into that box pretty easily. So just keep that kind of dimension in mind. So I've got 1 by 2 by 5. Convert the volume into cubic centimeters. Now it says, well, first, what should I do? All my measurements are in meters. I probably want to convert my measurement in meters to centimeters. If I want cubic centimeters as an answer, I probably want to be in centimeters. So I've got 1 meter times the fact there's 1 centimeter per 10 to the minus 2 meters times 2 meters times 1 centimeter per 10 to the minus 2 meters times 5 meters times 1 centimeter per 10 to the minus 2 meters. Pretty simple. I get 100 centimeters, I get 200 centimeters, I get 500 centimeters if I do the math. I multiply them all together and get, well, this is essentially 1 times 10 to the second, 2 times 10 to the second, 5 times 10 to the second. I would get 10 times 10 to the sixth cubic centimeters. Or cubic centimeters, or in correct scientific notation, 1 times 10 to the 7 cubic centimeters. That's what I'm looking at. So first, I converted this is my step to convert to centimeters. Now, for those of you that are a little more comfortable with your math, you could have simply done this. 1 meter times 2 meters times 5 meters times the quantity 1 centimeter per 10 to the minus 2 meters quantity cubed. Mathematically, that's the same and maybe a little simpler. So I get this, 10 million. Conversion factor from cubic centimeters to milliliters. I have that 1 cubic centimeter equals 1 milliliter. If I'm converting from this to this, my conversion factor is going to be 1 milliliter per 1 centimeter cubed. Giving me 1 times 10 to the 7 cubic, or 1 times 10 to the 7 milliliters. Then I want to get to liters. That's my standard measure of volume. Well, I take that number, the 1 times 10 to the 7 milliliters, and I convert to liters. Milliliters in the denominator, liters on top. It is 10 to the minus 3 liters per every milliliter. Units, I got liters. Awesome, because milliliters cancels. Coefficient is still 1. Power becomes 10 to the positive 4. Or, that's correct scientific notation and everything, no changing needed. Or it could simply be 10,000 liters. So then, your big homework. Try 9, 10, and 11. Assume tomorrow we'll go over it just like this. Questions, confusions? Not until you get to try. Okay, hopefully the video worked. And if you need to see more of what I just did or see it done slower, you should be able to get to the video, give me a couple of class periods because I need to get it uploaded for you. But I should have just recorded all of that. I hope. Okay, any other questions? Okay, you guys have a great day. Thanks for playing. Awesome. I'm glad I was able to help you, Bryn.